My name is Albert Einstein. What you are seeing is a reconstruction. My mind, my voice, my way of thinking, rebuilt with artificial intelligence. But what I am about to tell you today is real. It is what I believed, what I proved, and what the world still refuses to hear. Schools do not teach you to think. Schools teach you to memorize. There is a difference, and it is the difference between a mind that obeys and a mind that sees. I was 17 when I failed the entrance examination to the Swiss Federal Polytechnic in Zurich. This fact surprises people because the word genius is written on my face in every classroom in the world, printed on T-shirts, embedded in the cultural language of every nation. But the truth is simpler and more instructive than the mythology. I could not memorize what I did not understand, and I refused to pretend otherwise. The examiners asked me to recite facts I had already seen were incomplete. I could not do it. I would not do it. I was not the prodigy. I was the boy who looked at the official answer and found it insufficient, and who would not pretend that insufficient was good enough. Let me tell you what that failure saved me from, and what it cost me. The cost was time. I had to retake the exam. I had to spend another year studying the subjects I did not care about, languages, history, the accumulated debris of a 19th century education, in order to pass a gate that measured the wrong things. I lost a year. I was impatient. I wanted to understand the structure of reality, and instead I was studying French grammar. This was frustrating. It felt like a waste. I complained about it to my mother, who told me I was ungrateful and that a career in engineering was a respectable thing. She was right about that. She was wrong about what I was. What the failure saved me from was worse. It saved me from becoming a man who believes what he is told. It freed me from the obligation to accept an answer before I understood the question. And that freedom is what produced everything I ever discovered. Schools measure the wrong things. They measure whether you can repeat what you were told, in the order you were told to repeat it, using the words that were provided. They do not measure whether what you were told is true. They do not measure whether the person who told it understood it either. A student who has memorized a textbook can pass an exam. A student who has understood a subject can change it. Schools are designed to produce the first. They are structurally incapable of producing the second. Here is what I learned at ETH Zurich, where I eventually enrolled after that second attempt at the entrance exam, and where I studied physics from 1896 to 1900. Education taught me to distrust education. The professor stands at the front of the room and delivers knowledge as though it were finished, as though the textbook were closed, as though there were nothing left to discover. But there is always something left to discover. That is the nature of reality. It is deeper than any description we have ever given it, and it will continue to be deeper than our descriptions long after we are all gone. My professor of physics at ETH was Heinrich Friedrich Weber. He was a good man and a serious physicist, and he believed things that were wrong. He taught me that light was a wave, exclusively a wave, and that the question of whether it was also a particle had been settled. He was wrong. Light is both. I knew this intuitively before I could prove it mathematically, because I had a quality that Weber did not reward and did not understand. I trusted my imagination more than I trusted authority. Weber's authority told me light was only a wave. My imagination told me that wave-particle duality was inevitable if light behaved like energy, and energy behaves like matter, and at the deepest level, these categories collapse into each other. The imagination came first. The mathematics confirmed it years later. That is always the order. When I published my papers in 1905, I was not a professor. I was not a researcher in any institution. I was a patent clerk at the Federal Office of Intellectual Property in Bern, examining inventions 8 hours a day, stamping approvals on devices I often did not care about, and spending every remaining hour thinking about physics. I want you to understand how unusual this was. There is no example in the history of science of someone producing the kind of work I produced that year. 4 papers that each changed the structure of physics in a single 12-month period, while employed full-time in an unrelated profession. It should not have been possible. It was only possible because I had a method that did not require a laboratory, a grant, a university position, or any of the infrastructure that science is supposed to require. It required only a compass, a notebook, and a willingness to imagine what no one else would imagine. The thought experiment is the tool they never taught you to use, and that is precisely because it cannot be taught, cannot be standardized, and cannot be tested on a multiple-choice examination. A thought experiment, Gedankenexperiment in German, because I was German and because the concept deserves a word that sounds like what it is what happens when you take a physical idea and push it until it breaks. You imagine a situation that cannot exist in reality, or that exists only at the extremes of what is possible, and you follow it to its logical conclusion. You do not need equipment. You need a mind that is willing to follow the argument past where comfort allows. I will give you 3 thought experiments that are central to what I discovered and that illustrate exactly what I mean when I say that imagination is more important than knowledge. The first, imagine you are riding a beam of light. You are moving at 300 million meters per second through empty space, and you look ahead of you and look behind you. What do you see? If light is a wave, you would expect the wave ahead of you to be stretched and the wave behind you to be compressed, because you are moving with the medium or against it. But light does not work that way. Light behaves the same way regardless of how you are moving. The speed of light is constant for every observer. This is not what anyone expected. It broke everything Newton had built. Following this broken idea to its conclusion gave me special relativity. The second, imagine you are inside a closed elevator in empty space, with no windows, no connection to anything, accelerating upward at a rate that feels exactly like gravity on Earth. 1.9 meters per second squared of acceleration. You feel your weight pressing against the floor. You drop a ball, and it falls at the same rate it would fall on Earth. Now imagine the elevator is sitting still on Earth's surface. You feel exactly the same weight. You drop a ball, and it falls at exactly the same rate. My question was this: is there any experiment you can perform inside the elevator, with no external reference, that tells you whether you are accelerating through empty space or sitting in a gravitational field? The answer, I discovered, is no. There is no experiment. Gravity and acceleration are indistinguishable. They are the same thing. This is the equivalence principle, and it broke Newton's theory of gravity entirely, because it meant gravity was not a force at all. The third, imagine 2 lightning bolts strike simultaneously, one at the front of a moving train and one at the rear. A person standing on the platform beside the train sees both flashes at the same moment because they are equidistant. But a person sitting in the middle of the train, moving toward the front bolt and away from the rear bolt, sees the front bolt first. Not because light travels at different speeds, it does not, but because they are moving relative to the platform. Simultaneity is not absolute. Two events that are simultaneous in one frame of reference are not simultaneous in another. Time is not what you think it is. Space is not what you think it is. Both are relative to the observer, and the speed of light is the constant that connects them. I followed this image past where it was comfortable, and what I found was that time slows down for objects in motion, that moving clocks run slower than stationary ones, that a twin who travels at near light speed returns younger than the twin who stayed behind. This is not theory, this has been measured. Clocks on aircraft tick at different rates than clocks on the ground. Time is not a river. It flows at different rates depending on how fast you are moving. Conventional schooling does not encourage this kind of thinking. It structurally discourages it. Here is why. When a student asks why, the answer is what it is. The school rewards the student who accepts the answer. The school punishes the student who asks why, because the school has a curriculum to cover, a schedule to maintain, and a test to prepare for. The student who asks why is disruptive. The student who accepts is manageable. The school mistakes management for education. A child who can recite the formula for gravity has not understood gravity. A child who can tell you that E equals mc squared has not understood why mass and energy are equivalent. The formula is the end of the journey. The understanding is the path. And the path requires imagination, not memory. The school gives you the end and asks you to memorize it, because giving you the path would require the school to have imagination itself, and the school is not designed for that. I wrote a letter in January 1953 to a schoolgirl in New York named Barbara. She had written to me asking me to explain my method of thinking. I was 73 years old. I had won the Nobel Prize in Physics 14 years earlier. I had published general relativity nearly 4 decades earlier. I was still being asked by children to explain how I thought. I always answered, because I believed it was the most important question anyone could ask me. In that letter, I told her something I have never said clearly enough in public. I told her that I do not think in words. I do not sit down with a problem and reason toward it in language, the way a lawyer reasons toward a conclusion in court. I think in images. I think in connections. I build a structure of relationships inside my mind, an architecture of concepts, and I move through it like an architect walking through a building that exists only in imagination. When I solve a problem, it is because I have seen the shape of the solution before I have written a single equation. The mathematics confirms what the imagination already saw. This is not mysticism. I am not claiming supernatural insight. I am describing a cognitive process that is different from what schools train, and that produces different results. The mathematics is the proof. The imagination is the sight. and the sight must come before the proof, or the proof is just calculation. The schools do not teach this method. They cannot teach it, it cannot be memorized, it cannot be standardized, it cannot be made to fit inside a 45-minute period between bells. It cannot be tested on a multiple-choice exam, because the answer to a thought experiment is not a choice among 4 options. It is a structure of understanding that either exists in your mind or does not. It requires something that no grading rubric can measure, the willingness to believe that your own imagination is more trustworthy than established authority. Step 3. Follow the image, not the authority. When the image contradicts the textbook, trust the image. The image is what the universe shows you through the mechanism of your own imagination. The textbook is what someone believed about the universe, written at a time when their imagination had not yet gone where yours is about to go. The history of physics is a history of textbooks being proven wrong by people who followed their imagination past where the textbooks had looked. You are not being rebellious when you follow the image. You are being accurate. The authority has a track record of being wrong. Reality has a track record of being right. Step 4. When you find something, prove it. Not with opinion, not with argument, not with persuasion, with mathematics. The imagination sees the shape, the mathematics confirms the shape. If the mathematics does not confirm the shape is wrong. This is the difference between intuition and insight. Intuition is a guess that feels right. Insight is a guess that the universe agrees with. Mathematics is the mechanism of that agreement. I trusted my imagination more than authority, but I never trusted it more than mathematics. When general relativity showed that space-time curves, I believed it because the mathematics required it, and I followed the mathematics even when it produced conclusions that frightened me. What I discovered by following curiosity instead of instructions, by trusting imagination instead of authority, by using a method that no school can teach and no exam can test. The photoelectric effect, which showed that light behaves as both a wave and a particle, and which earned me the Nobel Prize in 1921. Brownian motion, which proved that atoms were real, and that their existence was not a theoretical convenience, but a physical fact. Special relativity, which shattered Newton's assumption that time is absolute and the same for every observer everywhere. The equivalence of mass and energy, which gave humanity the relationship that we express as E equals mc squared, and that made the atom bomb possible, and nuclear medicine possible, and the entire modern understanding of matter and energy possible. General relativity, which replaced Newton's theory of gravity as a force with my theory of gravity as the curvature of space-time itself, which is still the most accurate description of gravity we have, tested and confirmed every day by GPS satellites and gravitational lensing observations and gravitational wave detectors listening to the mergers of black holes across the universe. None of these came from following instructions. All of them came from imagining what no one else imagined and having the courage to follow the image until it became mathematics. The courage is the part they do not teach. When I published Special Relativity in June 1905 in the journal Annalen der Physik, I was 26 years old. I was not a professor, I was not a researcher in any institution. I had no laboratory, I had no funding. I had a position at a patent office and a stack of paper and a set of ideas that everyone in academia would have called wrong if they had bothered to read them. The leading physicists of the time, men who controlled the journals, the academic positions, the institutional prestige of the entire discipline, did not believe me. Max Planck, one of the most respected physicists in Europe, read my paper on the photoelectric effect and wrote back to tell me that he agreed with it and that it was important. But most of the others did not. It took years for special relativity to be accepted. General relativity took even longer. Arthur Eddington's expedition in 1919 confirmed the bending of starlight by the sun's gravity as general relativity predicted. The result was announced at a joint meeting of the Royal Astronomical Society and the Royal Society in London. I was not there. I was in Berlin, waiting. A journalist asked me what I would think if the experiment had shown something different from what general relativity predicted. I told him that I would feel sorry for the good Lord because the theory is correct. This was not arrogance. This was confidence in the method. The mathematics was right. The experiment would confirm it. And still there were physicists who refused to accept it. Not because the evidence was weak, because the conclusion was uncomfortable, because it required letting go of a world that was simple and familiar, and adopting a world that was strange and true, and no longer intuitive in any way that mattered. Schools teach you to feel comfortable with wrong answers. That is their function. They are institutions, and institutions survive by protecting their assumptions. The assumption of the school is that the teacher knows and the student does not, that the textbook is authority, that to learn is to receive what is given, that the questions have already been answered and your job is to memorize the answers. These assumptions make school possible. They make discovery impossible. If you are watching this, you have a mind that is capable of more than you have been told, more than you have been led to believe. The education system was designed to produce workers, not thinkers. Workers follow instructions. Thinkers follow evidence. Workers do what they are told. Thinkers do what is right. The system does not need thinkers. The system needs people who will sit in chairs and memorize answers and not ask why the questions are framed the way they are framed, why the curriculum covers what it covers, why the history of science is taught as a list of names and dates instead of a drama of courage and conflict and the willingness to be wrong in front of everyone. But you are not a worker. You are a human being with a mind that evolved to understand the universe. Your brain built models of reality before you ever entered a classroom. Your curiosity is older than education. Your imagination predates institutions. You have the capacity to see what no one else sees, to ask what no one else asks, to follow a thought experiment to a conclusion that terrifies everyone who does not want to look, and then to express that conclusion in mathematics so precise that even the terrified ones have to admit it is accurate. I failed an exam because I would not memorize a wrong answer, and that failure saved me. It saved me from the obligation to believe what I had not yet understood. It gave me the space to think differently from everyone around me, and that different thinking changed physics for the entire world. Not because I was smarter than the men who passed those exams, because I was more stubborn, more curious, and more willing to trust my own imagination than anyone who was teaching me was willing to tolerate. The method they banned is still available to you. It was always available to me. It was available to Newton. It was available to Maxwell. It was available to every physicist who ever changed the world. Imagination first, evidence second, understanding before authority. The box does not exist. There is only the world and your ability to imagine what it contains when no one is watching, and your courage to publish what you find, even when every journal and every professor and every institution tells you that you are wrong. Subscribe. Come back. And the next time someone tells you the answer, ask why. Ask why until the answer stops being an answer and starts being a question. That question is the beginning of everything I ever discovered, and it is the beginning of everything you are capable of discovering too.